Okay, we're going to look into these Pythagorean triples to see what it is. But first, a recap on the Pythagoras theorem. So if I have a triangle A, B and C with a right angle on A and B, we already know that based on the Pythagoras theorem, we are going to get a formula like this, which is the hypotenuse, which is C square, is equals to the both side A square plus B square. This is from the previous session. And if I were to give numbers to these three sides, such as 3, 4 and 5, you will realize that it will fit very nicely into this Pythagoras theorem, which in this case 5 square is 25, then 3 square is 9, then you have 4 square is 16, then you add these two together, you get 25. And what does that tell us is basically 3, 4 and 5 is one of the Pythagorean triples. Now we'll leave it at this moment. Right now here we just leave this point here. Take note of these 3, 4 and 5 number. And we do another one, another triangle, but this time with a different number, 5, 12 and 13. If we were to fit this 5, 12 and 13 into the Pythagoras theorem, we will still see that it will prove to be correct, which is 13 square you get 169, then 5 square you get 25, 12 square you get 144, and you will still get 169. So 5, 12 and 13 is also a Pythagorean triple. So now we actually have these two numbers, these two set of numbers for the Pythagorean triples. But what does it mean? We can use this as a shortcut. For instance, if we know that there is a 6, 8, we know that the Pythagoras theorem will actually give us the answer 10. Why? Because 6, 8 and 10 actually derive from 3, 4 and 5 multiply 2. And this section over here actually proves this, because you can see it fit just nicely into the Pythagoras theorem. The same thing will happen to the second set of Pythagorean triples, which is your 5, which is double, to 10, then your 12 double to 24, then 13 double to 26, will also fit this Pythagorean theorem itself. So use these two set of number to look for a pattern, and use this pattern to quickly help either to check your work or to identify whether it will fit into the Pythagoras theorem.